Hi folks, this is the video tutorial for chapter 11 of my textbook. The title of the textbook is Composite Finite Element Analysis Essentials for 3D Experience, and the title of the chapter is Mandrel Pressing on a Woven Fabric Composite Strip. So the problem that we're going to be doing is a plate that is a laminated composite, and it's made of two woven fabric, carbon epoxy woven fabrics. Okay, so the ends of the plate are clamped, as you can see, these two ends, and in the middle, I have a mandrel, which we're going to assume it's a rigid surface. Okay, it's a rigid object, and it is positioned above the plate, and it's pushed down by 5 millimeters. The dimensions of the plate are given here, and the total thickness of the plate is 4 millimeter. As you will see, there's going to be two woven fabrics here, one below it, and I'll come to that in a minute, and one above it, and each of those layers are 2 millimeters thick. So the mandrel initially sits against the top edge without any interference, so barely touching it, and then it is being pushed down by 5 millimeters. The dimension of this radius is given to be 15 millimeter. And the other thing you should be aware of is that, let me first show you the geometry here. So the top is woven fabric, and we're going to orient it at 0. Of course, the other direction is going to be 90. And then the bottom is the same fabric, but it's rotated by 45 degrees. Okay, so the top lamina or ply is 0.90, and the bottom one is plus 45 minus 45. Now, the data here for this particular balanced plain weave fabric is taken from uh, the well-known book down here, and the moduli in the fabric, in the longitudinal and transverse direction, are given here. And obviously, if this is a balanced plain weave fabric, these two numbers are the same. There's a small Poisson ratio because moving in one direction, because of the fact that this is a woven fabric, uh, creates very little strain in the other direction, transverse direction, and the shear moduli are given here. Okay. Uh, yeah. So we're going to do this now. The one thing you have to realize, because you're solving this thing as a mandrel pressing against a composite laminate, we have to solve this thing as a contact problem. So this is the first one in the first problem in the last 9 or 10 chapters that we're actually doing an assembly. So here we have to start with an assembly, and in the assembly we're going to put the plate, and then we're going to put the mandrel, and then we go ahead and solve the problem. Okay. So I have already created an assembly here. So all I did was to go to the robot, what used to be called Compass, and then selected the assembly design. And of course, when you do that, it's going to put you in the assembly design workbench, and right there. Now, I have two choices. I make, uh, Either I already made those two parts and I'm going to bring it in. So if you put the cursor there, right click, and under insert, you're going to see several options. One of them is if you already have created it, existing 3D shape, you bring it in. That's one way of doing it. On the other hand, if you're going to make it right now, so just say insert 3D part. Okay, so that's what I'm going to do. So the first one, that first one is going to be my plate. You will see, okay, right there. Let me make this thing bigger so that we can see it right there. Okay, very good. I'm going to change the name of this to the plate. Okay, video plate. How about that? So properties, video plate, okay, and say okay, right there. Now I can insert the other one too, or I can make this model and then come back and insert it as a different part. So let's do that at the same time, just like I did in the book. Right click, insert 3D part, and I'm going to rename this thing to be video Mandrel. How about that? Video Mandrel. Okay. All right. So let's go ahead and make actually this plate. Okay. So I'm going to double click. I'm going to double click on the 3D shape up here. Okay. And right now I'm in composite design, which I don't want to be. I want to be in the generative shape design. So let's put it in there. Right there. Okay, so I'm in generative shape design. Okay, very good. So on a convenient plane on the XY plane that I've done, I am going to sketch, sketch. Okay. Uh, see for a second. Okay. I'm going to sketch a rectangle which is 1,000 millimeter by 250 millimeter. The only thing I want to see whether I did it in the book as centered at the origin or not. I don't think it really matters. I'm going to center it at the origin. Yeah, let's do that to avoid using assembly constraints. So here is a right there, centered rectangle, centered here, and then we're going to put dimensions 1000 along the x, 1000 millimeter this way, and in the horizontal direction 250. Okay, there is my sketch for the plate. We are pretty much done here. We exit and we go to the surface. There's a surface, and fill it, F-I-L-L. There we are, and it's filled. Okay, now what I'm going to do, I will create an access system here because I need a rosette. So we might as well do the access system right now under essentials. There's the access system. By default, it puts it the global origin, and this is fine with me. And I always uncheck this current. That means that the global coordinate system is current, not this axis system. Although it really doesn't matter because this axis system is actually coincident with the global coordinate system. All right, good. So that takes care of this. Well, let's just save this thing. Okay, now let's go and make the mandrel. Now, in order to do the mandrel, I have to move into this part. So make sure you're not there anymore. You double click on 3D shape down below in the mandrel so that you don't accidentally make the sketch in the plate. Okay. Now, on the XZ plane, sketch. Now look, if the way I'm going to make this is to make sure that when I'm done, the two parts are in the proper position. If you don't do that, then you have to use assembly constraints in order to put them, position them properly. Okay, so here's the situation. If you look at this drawing, I'm going to make it 15 millimeter, the radius of 15 millimeter, and it's going to be 2 millimeters above the reference surface. Okay, so let's make an arc here. There is the arc. Let's give it a radius 15. 15. Okay, right there. Okay, bring it down. So dimension between the center of this guy and that plane 17 millimeters. 5 millimeter to account for the radius, and 2 millimeter for the gap that I mentioned that. Okay, so that's pretty much it. There's nothing else to do here. Exit. Okay, now I'm going to create my surface by extruding this. There's the extrude. And okay, you can see that it already did that, but I want it to be mirror extend. This is mirror extend, see that? In both direction, and half the length 125, which means overall the cylinder or semi-cylinder is going to be 250. Right there, and we say okay. All right, good. Now let me change the color of some of these things. Actually, let's. Oh, before I do that, let me create my reference point. Remember, I need a reference point which is going to control the motion of the mandrel. The location of this point doesn't matter, but I'll make it so that it's 30 millimeters above the reference surface. Okay. So here's the point. You go to Essentials. Here's the point, and the coordinate is 0, 0, 30. 30 millimeters, that's what I meant. 30 millimeters above the plane. All right, good. So if you look at it carefully, you see that there's a point here, and this is 30 millimeter away from the reference surface. Although that height really doesn't matter. Okay. So let's go to the assembly design. Save everything. Very good. And I want to change the color of this guy. So to do that, I go to 3D shape for the plate. Let's see now, we have a surface here, fill, right click properties. I'm going to change the color of that to yellowish. Okay, that's better. Okay, I'm looking at the content of the chapter to see what is it that I did next. I'm pretty sure I defined the material properties next. Yes, okay. So in order to define material properties, there are different ways of doing this, but this is how I did it in the book. Let's go to one of these parts. Say it's in the plate right there. Right there. Yeah, not in the assembly design. You go to the part right there. Okay. I'm in the plate. See that generative shape design, and under tools you have add material. Create a material. Okay. I'm going to give this thing the name video plate. Okay. And that's pretty much it. So we say okay. Just be patient. It's going to come. A video plate right there. So you right click. Now, this first, let's define this composite property. So composite, the thickness of the compute thickness is 2 millimeters, and it is, I mean, it is bidirectional, although it really doesn't matter here because this is not used in FEA for FEA calculation. It's good for bill of materials and many other things. But for us, even if this was made unidirectional, it'll work. But to remind me that this is a fabric bidirectional, you say okay. All right. Now right click, simulation. So let's put that table that I showed you in the slide. So abacus multiphysics, and it's mechanical, elasticity, elastic, and it is lamina. And now I have to put those numbers for you, these numbers in there, okay? So put down 54 MPa, 54,000 MPa, which is actually 54 GPa, okay, that's fine. 54 GPA. That's exactly what this number is for GPA, okay? And then 0.045, 0.045 for Poisson ratio, and then these are 4. These are each 4. 4 and 4 and 4. 4. Oops, right there. And then we say okay. All right. Now let's save this. I want to remind you that in the previous video, chapter 10, I mentioned that you don't have to apply this material here. In the first 9 chapters, I did apply, but it really didn't matter because this information is going to be read by the composite parameters anyway. So whether you apply this thing or not is totally irrelevant. So I'm not going to do that. So say fine, save everything. Now, I want to have direct access to that material that is just created. And what I have suggested is if you go to the assembly level right there, assembly level there, and then you say material, you go scroll down and select material definition. So what happens immediately, a material editor tab opens up, and in it, it puts the material that is in session. Remember, this is the material in session. I just defined it, okay, right there. Don't worry about this. This is the covering material of the same thing. Okay, this is what I need. The numbers that I want are here. I can always check it. Double click on it, for example. These are the numbers that I put in there. Close it. Okay, let's save everything. All right, so when I look at my chapter, I already did this. Now we're going to go to composite design. We're going to go to composite design right there, composite design. Oh, okay, so what happened? It took me to another file. I don't want that because I want to define the composite parameters for this part. So make sure you're not at the assembly level. Make sure you're not up there. Double click on the part so that you're in, you're in the part, okay, not in the assembly. And so when I did this thing, composite design, if I had double clicked there, I would have ended up with this action pad that you see down here. So you have to be in this part because you want to make this thing a composite part, not at the assembly level. Okay, good. So first thing we're going to do is apply. We're going to do this thing with ply design because only 2 plies really. Composite parameters, add a material from the database, and that is the reason I created this tab here, because I have direct access to this. I don't have to search or anything. And it's going to populate this right there. And then the only thing that's missing here is the rosette. Add a rosette, and remember I created an access system here that I can use it now. As soon as I do this, it creates the rosette, but you can't see it very clearly right there. Excuse me. So, sorry. So let's make this thing 200 so you can see it better. Right there, too big. Yes, it's too big, right there. It really doesn't matter because I don't need this thing anyway. I'm going to hide it. Okay. It's just that I wanted to show you this so that you don't panic if you see something big appearing on your screen. You can change the size of that rosette. Okay. Let's see now. We save everything. Since we are doing plies design, okay, so the next thing is to say plies group. It's going to ask you about the surface. There's a surface. Keep the draping direction up, and we say okay. All right, now we're going to create our plies. So this is the first ply, and again in the book I say nothing happens. You click on this because if you read the bottom left corner of the screen, it says select ply, group, or sequence, or ply to create it. Okay, so I have to go and select this ply group 1 that I created right there, and now something happens. So for the sketch, this is the first ply which is at the bottom of this plate. Okay, because I will select the draping direction upward. That's what it was. So we can go and select the sketch out of this. Notice that it picks this entire thing. And here under attributes, that one has plus and minus 45. Okay, that's the bottom ply that I'm doing. You say, okay, we do another one in that ply group, same boundary and attributes. Now this is going to be 0. This is the second ply on the top of the plate, and we say, fine. Okay, this is done. If you want to see it, it's always a good idea to check these. So you go under review, on the ply exploder, you select your plies group and say apply. Notice that you get two plies. This bottom one is, of course, you can see this is the reference surface, okay? And there's the mandrel, okay? And don't let this thing bother you. Eventually, we'll position this so that it goes half of it up, half of it down above that reference surface. But anyway, gray is 0 orientation and red is 45 degrees. So that's correct. Cancel that. By the way, if you do this, it shows you in the form of a solidish. Cancel. Okay. All right. So what is the next thing that we're going to do? We are pretty much done here as far as the model is concerned. Now, I have a warning for you in the book. The next thing to do is to go and mesh this. But I have a warning in the book, and it says, look, make sure you are not in the part. Make sure you're in the assembly level. See, this says composite part, composite design. This is at the part level. So double click on the top level so that you go to the assembly design. Now, you can do the problem if you're in part, but the way I've explained it in the book is do this at the assembly level. Okay, this has to do with the concept of mesh of the assembly or assembly of meshes. The approach that we're taking is mesh of the assembly. In other words, when I create my element, it's going to be directly below that top line. If you do it at the part level, the mesh is going to be below the part, not below the assembly. Okay. So that's what we do. We're going to go there. We're going to go to structure model and defaults. Notice that it's going to put it right there, right below the first level, right there. If you're not at the assembly level, then it's going to put it underneath, and there are other things you have to do. Okay. Now, uh, yeah. So we're going to mesh this thing first. So remember, you can either mesh it first and then apply properties, or you apply properties and then mesh it. In the book, most of the time, pretty much all of the time, I've done meshing first. You mesh, and we're going to do the surface quad mesh, and it's going to be that surface. And I believe I'm taking a. Let me just bear with me for a second. I wonder how. Oh yeah, in the book I'm saying that 10 millimeter. Use 10 millimeter. We can always change this, of course, and quadratic right there, parabolic right there. Apply, and this is your mesh. Okay, we say okay. Good. Notice that there are no properties here. So now we have to apply the properties. So you change this thing to model. Okay. And on the properties, we're going to get the composite shell section. So the support is that is this basically this fill. Okay, you can either do it from here or you can do it from there. It really doesn't matter. So if you say fill right there, and for the composite, I do it by ply, and it says, oh, what did they say? I meant to say by ply. Okay, right there. Okay, yeah, and we have a ply here, which is right there. I expanded this thing there, ply group 1. You can take it from the tree too. Okay, you could have taken it from the tree. Now, under advanced, we're going to go to offset, none, 0. And this tells you that these two ply 1 and ply 2, you place it so that the plate is exactly halfway between it. There is no offset between that ply group and the middle surface. Okay, so in order to have something like this, the reference surface to be like that, so that 090 is above and plus or minus 45 is below, you say 0 offset. Okay, none. And then you say okay. And then save it. Okay, so notice that the nodes have been created, nodes and elements have been created, and then properties have been created. Now we want to create our uh, Mandrel, rigid surface. So you have to go under abstraction. See that? Abstraction. You're in the model. This is the model. You're on the abstract. You select the abstraction. And over here, you select the analytical rigid surface. Analytical rigid surface. It is true that you can mesh that mandrel and then create a contact between mesh of the mandrel and the mesh of the plate, but really there's no sense in doing that. You have no reason to mesh that mandrel because we are assuming it's rigid. So analytical rigid surface. Now be careful here. This is very important. Oh yeah. So this thing was, you can take it from the tree or from the screen here, it really doesn't matter, but it was that extrude that I created, right? It was this extrude right there. So you can select it from here or you can select it from there, it doesn't matter. And there is a point, and that point is the point that I created as the remember I created by as a reference point. So let me see if I can do it from here. Okay, I had a hard time picking it, but it's okay. So right there, right there, right there, or from the screen right there. It really doesn't matter. But it did take it. You say okay. Incidentally, uh, let me show you what happened here. As soon as you created that analytical rigid surface, let me move this thing out of the way. This is where you had your nodes. This is where you had your shell property, composite shell property, and this is where it was created. This is where the analytical rigid surface was created. Let me double click on this. Now, I'm going to flip the direction, okay? And because sometimes you may try to run it, analytical rigid surface does have a direction, okay? If it doesn't work with one, come and flip it here, okay? So notice that the difference is that this is kind of very, it's got a texture here. When I did this thing, the texture is not as much, okay? So anyway, if it doesn't work, then come and do it the other way around. I'm not sure whether I had that issue with the book or not, but I don't think I actually flipped the direction. I don't think I flipped the direction. So let me not flip it, and because I'm going to be consistent with the way it's done in the book, and see uh, whether we run into a problem or not. Okay, good. Save everything. Okay. Now, here's the other caution that I give you in the book. We have to go to, first of all, we have to go to scenario, structure scenario creation. It's a structure problem. And you get your good old 2 exclamation marks here. Okay. So the first one to fix is to go to setup and select your finite element model. And this is the only thing that I had, right? It's the only finite element model that I had. And immediately this becomes green. Then you go to procedures, and this is a static procedure, static step, and make sure you uncheck the include any geometric nonlinearity under advanced, expand the advanced, and say okay. Now you have to go and select the restraint. For example, these ends are clamped, etc., etc. Now before you do that, I've always said in the book, what you should do is you should try hide a few things. For example, you go to your model, right there. First of all, hide the sketch. Hide the sketch. Because after all, I want to go and select these end edges. Okay. The problem is right now when I select this, this is not an edge. This is boundary of apply. See, stacking six, picking the stacking sequence. So hide this. Now when I select this, it's going to be an edge. I don't want to see this mesh either. So let me right click, visualization management. Don't show me the mesh. I don't want to see it. Good. Okay. So I hid a few things. All right. So on the restraints, this, uh, oh, yeah, on the restraint, I want to clamp this end and that end. You say okay. And I want to push, remember this point? I want to push it down. So I'm going to say fix displacement. That point should not move in the direction X or Y or rotate about X, Y, Z axis. All I want to do is to push it down later on. So I just leave this thing available. Okay, very good. And okay, so now we're going to go to loads. And under load, I want to take this point and translate it down. See that? Apply translation. You click on it. You go and select that point if you can from the screen. If not, from the tree, it really doesn't matter. Right there. This is supposed to be, if the force that's causing that thing to go down, but I'm not going to specify the force. I'm going to specify the value of displacement. And I'm going to say minus 5 millimeters. Minus 5. Okay. All right, very good. Let's save everything. There's only one thing. If I run this now, it will bomb out because the plate doesn't know that there's a mandrel coming towards it, and the mandrel doesn't know that there's a plate sitting underneath it, basically preventing it from move. So this is where you have contact. So you're going to go under interactions, and it's a surface contact right there. See that? Surface contact. Now be careful. There's two things you have to select: a main surface and a secondary surface. Okay? The main surface, if you have a rigid surface, it has to be a rigid surface. Okay? There are some guidelines as which one do you pick, but as far as the rigid surface, if there is one, this main must be rigid surface. So I select it. Now make sure you don't take, if you see, the problem is that if you take it from here, it's going to take a face. That is not my rigid surface. Let me uncheck that. Remove it. Don't take it from here because it will not run. You have to go under the abstraction and select it from analytical rigid surface. Right there. That makes a big difference. And for the secondary, select that surface of the plate. Now, it's possible to swap these. We don't want to do that, but this is fine. We just do it. There's a lot more to this contact business. There may be friction and things like that. So it's not as easy as it looks like, but there's no problem here. It's a simple problem, and it's going to work. Okay, so we created our interactions. Now, these things are all created over here in the step. Of course, you can see that there is interactions, and it tells you what you did, etc. Now, before I run this thing, I want to ask for some output. Okay, so simulate. Okay, I want to ask for some additional output because I want to be able to look at the, for example, the couple of things. I want to be able to see the stresses in the two plies at different locations. So I'm going to click on this, and then this is fine. We want stresses, and we wanted by plies, by layers, okay? And we want it at all three locations if needed. Now, the other thing is that if you want to know how much force you need to do this, you have to ask for some more information. So let me show you how you do that. This is yeah, show how you do that. So you go to again output, okay? Now we want the forces and loads right there. We want the reaction forces, all of these. Let's check all of these. If you don't ask for this, you will not be able to see the force needed to push that thing down, etc. So basically, ask for all of them. You don't need all, but you know, there must be an easier way of doing it. Oh yeah, it was all selected. Okay, very good. And yeah, it's good. Okay, save it and run. Let's check this thing first. Model and scenario check. Hopefully no error messages. Okay, good, that's good. Then you do model and scenario check. Oh, already did this. Cancel. This one, simulation check. I'm sure there will be some warnings, but in all likelihood there won't be any errors unless I forgot something dramatic. These are only checks, they're not even running yet. Good. And close it. And now you're going to run it. Yeah. If you're dealing with severe impact and contacts and things like that, then you need to get the license to, or the permission to run explicit version of the software here. Right now, this is implicit version, okay? So, but these problems are very simple, so it really doesn't matter. But if you have bird strike and, you know, other things like that, you need to get the explicit license. Okay, I think extracting result, that's good news. So we close this thing. All right, so this is the initial frame, no load applied. So let's go to the second one. Look, it went through it. It did go through it. It didn't see it. Remember that flipping of the direction? That's probably what happened. So click. So let's go ahead to analytical rigid surface. There is two ways to do it. Let's try this one first. Analytical rigid surface. Let me flip direction. Say OK, and now go run it. So back to scenario. I'm not going to bother checking these, so I'm just going to run it. This probably could have been also taken care of in the interaction when I did the contact interaction. I think it's possible to change something there to work. But anyway, all I did was to flip it here. Let's see what happens. See if that direction, the direction of the analytical rigid surface, is not the correct one, basically contact is not going to be detected properly. This guy didn't see anything blocking its motion. Okay, so let's see. Extracting results. Hopefully it's going to push the plate down now. Okay, yes, right there. Now, remember, you can set this is, by the way, this is the one meso stress. If you want to see the displacement right there, okay, about 5.1 millimeter. And let me tell you something, and that is if you want to set the scale here, because this is dramatic scales, you click on the contour plot, go to the first tab, no, not the first tab, second one. The scale is, let's make this thing, I don't know, maybe uh, 1, okay, true scale. There, you can see that. Okay, now, this is the one meso stress, but I want to show you the displacement. Show you the displacement. For the displacement, set the scale 1. Oh, actually, this is yeah. I want a displacement. This is not the displacement. Displacement. Okay, displacement right there. Double double click on it. You can do that. Double click on it and set the displacement to 1. There, look. What I want to show you is that if you could look close enough, you look at the view from the front, you see that there is always a 2 millimeter gap there, because that's the half the thickness of the plate. So just be aware of that. Okay, so this is this, and let's actually set the scale back to 19. That's what it was. It's very dramatic. Okay, so if you want to see other, entities, double click on this, and first tab right there, the pencil. Okay, and these are the translations, but close that. I want to go to the stress, one meso stress. Okay, double click on it and change this thing to component of the stress. Oops, wait a minute. S component overall. I don't want overall, but I want these two plies. So ply 2, for example, the bottom, and apply. So that shows you the von Mises stress distribution, at the for ply number 2. I think that was ply number 2, and it is at the bottom of the plate. Okay, so this is fine. Uh, Now the other thing is, because you ask for all kinds of location, you can do the bottom, you can do the top, or you can do the middle, right there. Okay. The last thing that I want to show you is how much force is needed to push this thing down. Okay, and to do that, you go here, scroll down under resultant tensor, right there. You click on it, and okay, so what you do is, for example, you want the resultant force where? At the load or at the restraint? Restraints are the clamp, the two ends, and load is where you apply the downward displacement. So, for example, if you say at the restraint, remember I had a clamp restraint and apply. First of all, it shows you a few things right there. It shows you two numbers. One of them is the moment, of course, is 0, but this one is 42 Newton. And if you, by the way, if you did the clamp, you'll get the same thing. So you go down here, you can also see it down here in the tree. It's recorded here. And where is this? Let me move these things out of the way. Move this thing. So right here, resultant sensor. These are the ones that you asked for, 42 Newton. Okay, folks. So that'll do it for this video tutorial. Good luck.